Good afternoon. This is Chris Riley with System Source. Thanks so much for joining us for today's webinar, and hopefully you're going to enjoy some pizza here while we speak. If you ask for a pizza, so joining me today is Alex Wilson, who's probably almost a decade and a half now into wireless engineering, project management in there, from everything from very small office environments all the way up through very large facilities that we'll talk about today, including tower work, microwaves, other types of things. So if you're thinking wireless, Alex brings a lot of expertise to that party. So welcome to Alex as well. So let's jump right in here as we kind of learn about the whole the Wi-Fi for large enterprise and challenging environments. So we'll be looking today at kind of where are we today with wireless, but what also defines a challenging environment? What makes it challenging? What are the issues around that? And then more importantly, how do we kind of work around those challenges? So you'll probably see yourselves in some of the scenarios that Alex talks about today, and then he'll give you some information for how you can kind of address the kinds of planning challenges that you might have there, performance challenges that you have, and particularly through looking through case studies, which is always a valuable way of learning. All right, a little bit of housekeeping here. So you may want to note the email address for Mike Jones. It's right there on the screen. So if you do not have your pizza yet and you asked for one, go ahead and note that down. Wait a couple minutes, wait to see if the delivery driver is trying to find the front door of your building in your office building, or if you're working from home at your home. But if they still haven't come in a few minutes, just reach out to Mike and he'll do his best to try to help you out with that. During the webinar today, the audio is in presentation mode, so you'll be able to hear Alex and I, but we keep it in presentation mode, which means unfortunately we can't hear you. But we do that so that any background noise where participants may be, or if they've called in and they need to put the call on hold, music on hold, all those types of things don't come through the whole group, which could obviously be very distracting. So, but you can reach me at any time through the chat tab in GoToWebinar, as well as just submit any questions that you have, which will just put those right into the questions tab, and I'll read those out to Alex at the end, and we'll be able to address those questions in Q&A at the end. This presentation and the recording, you'll also receive that by email later today, so that you'll have that as a reference. And then finally, we do really kind of value your evaluation feedback. Let us know how we did so we can do better, but also to give you an opportunity to say, what do you need more of? So we'll try to make that fun. If you complete one of the evaluations, then we'll do drawings for for two of those, for either Amazon gift card, or we'll send you a gift card, $50 for your favorite restaurant. So hopefully you'll make it a little bit more fun to take the 1 or 2 minutes to do the evaluation. So a little bit about System Source for those who are joining the call today. Welcome, that are newer to us. So System Source, we've been around since 1981, and there are about 75 of us here. So we work with principally IT professionals in organizations from South Central Pennsylvania down through all of Maryland into the DC area. And folks a lot of times first come to us when they need to acquire new technology, whether for end user computing types of things, laptops, desktops, printers, those types of things. But the bulk of what we do is in the modern data center, whether that's the traditional on-prem, whether that's in Amazon Web Services, it can be in co-location centers, it could be in a variety of areas, including SaaS for software as a service. But we do a lot of our work today in Microsoft Azure, and as well as in Amazon Web Services, and have been doing that for many years. So when clients come to us with a problem, whether that's for implementing new technology, IT infrastructure, or for security or other types of things, we can kind of look to install it and implement it really in the best place, whether that's on-prem, one of the cloud, one of the co-location, or other types of locations, whatever makes sense for the particular client, their background, where they are today, preferences, etc. So we're going to be working with things like storage and servers from Hewlett Packard Enterprise, HPE. We're looking at security types of solutions from Arctic Wolf, from Cisco, Cisco Meraki, from Barracuda, as well as many other providers. We're also going to be doing work with VMware, the whole Microsoft stack, and the list kind of goes on from the types of technologies and the types of companies that we work with to design those solutions. Under improved, because people don't acquire just for acquisition's sake, they're really doing it to improve. So I've kind of mentioned a lot of things just kind of tangentially for our consulting and our cloud services. Our consultants are designing, implementing, securing, troubleshooting, supporting all those types of data center solutions that I just mentioned. Our training group is actually doing the training on those types of things, including in user computing side. So same technologies, similar, same manufacturers, and actually several dozen more that they're doing training on in the hundreds of courses that they have available at any one point, all of which are available virtually. And present is kind of our code word for professional AV. So thinking digital signage, and then plus all the Zoom rooms, Teams rooms, WebEx rooms, et cetera, that is all part of our hybrid work environment today. So we're going to be putting in the monitors and speakers and microphone systems into conference rooms, huddle spaces, presentation spaces, including even up to audio in stadiums. So we're really looking to say, how do we kind of make that hybrid environment that we work with productive, to make sure that all the cameras and teams and everything else we're working on works well when you go into those spaces at your office facilities. And finally, we maintain all the things above, either on a reactive basis. You call us when things go bump under service and support, and that can be done 7/24, whether you have a contract with us or not. Don't worry about that. You can always call us after hours and follow the voice prompts on our system, or managed services where we are the IT department for dozens of organizations. Just like many of you are the IT departments for your organizations, we're also the IT department for other organizations as well, or co-manage with folks like yourselves. And that's how we maintain things. So we do have one upcoming webinar. So it's the summertime, so we slowed down a little bit there. If you're familiar with our webinars, you know we have a number of events, and that we'll have a whole new fall series of events starting in September. But next month we do have one on building Power BI dashboards. That's been a very popular topic, and that's coming up on the 8th. I will drop the registration link in the chat, and when you get this PowerPoint, that is a clickable link if you wish to sign up there, or just go to our website. And with that, let me hand the reins off to Alex, please.
All righty, well, good afternoon, everyone. I would like to talk to you a little bit today about where we are today. So we're going to start off real quick with a level setting about Wi-Fi 6, Wi-Fi 7, make sure everybody understands the differences. Then we're going to get into a lot of different things about large, complex, unique environments. We'll talk about some case studies. We'll talk about some definitions of what defines these types of environments. What are some of the common challenges that you may run into, and that'll spark some conversation or some thoughts in your mind, hopefully, of how you can get yourself ready for that next leap into a new technology standard. So let's just start talking real quick about reality versus marketing. So there are two organizations that drive the standards. IEEE is the standards committee. This is a organization, it takes years to adopt a standard. Right now, they're currently working on the Wi-Fi 7 standard. Keep in mind that even though you'll hear a lot of hype about it in the marketplace, especially on the consumer side, it has not been ratified yet. And so it is subject to change. And I mean, the chances of it changing dramatically are very slim. However, certain functions or features could end up either dropping out or being added back in. They're expecting ratification by the end of this year. The current standard, which is 802.11ax, or also known as Wi-Fi 6, was ratified back in 2021. There was a lot of confusion back then about the whole thing because it was ratified, and then later on, people were getting confused about what does it include. And so that's where the Wi-Fi Alliance comes in. And the Wi-Fi Alliance is a marketing organization, and their job was to come up with a new name. The reality of life is 802.11 is something that a lot of people don't understand. It's a very complex terminology that makes it difficult for people to keep it straight. So what they did was they came up with these naming standards. So Wi-Fi 5, Wi-Fi 6, Wi-Fi 7, and that described or essentially equated to a standard. Where the confusion came in was with Wi-Fi 6. Wi-Fi 6 does not mean 6 gigahertz support. It simply means they support 802.11ax. Now, there is an extension that allows for 6 gigahertz in the Wi-Fi 6 protocols, and that's called Wi-Fi 6E. Wi-Fi 7 includes 6 gigahertz, but something to keep in your mind is that it's not required. And so this has actually started to create some confusion in the consumer market, where some companies are releasing Wi-Fi 7 access points without 6 gigahertz radios in them, and people are looking for the 6 gig support and they can't find it. Well, it doesn't mean it has to have it. It just has to meet certain other requirements. And so the Wi-Fi Alliance is about meeting certain requirements, whereas IEEE is really setting the standards that everybody has to follow. So whatever happened to Wi-Fi 6? I mean, you know, it just came out, and here we are already talking about Wi-Fi 7, and in many corners they're even talking about Wi-Fi 8. So it is still available. It is still the current most readily available standard. There were slow adaptation rates due to all of the supply chain issues, the post-COVID cutbacks, confusion over the industry, and some people were waiting for 6E, some were waiting for 7. Vendors are still releasing new products in this space. Expect to see more, especially on the outdoor side, because now that the automatic frequency clearing database has been approved, they can now offer 6 gigahertz in an outdoor environment. So if you have an access point today that is tri-band and you put it outside, technically you are violating FCC regulations, unless that access point was designed to be supporting 6 gig in an outdoor environment. And that requires a GPS, it requires a gyroscope. There are a couple of other items that are required in it. And the idea being is that it's to look up for licensed frequency use in your area of 6 gig and avoid those channels. So that's our AFC, the Automatic Frequency Coordination Database. The 6 gig spectrum is licensed, mostly long haul microwave links. So if you're downtown, you could run into it. If you're out in the countryside, you probably won't have this big of an issue. The good thing is, if you have an issue, it's probably with a single channel, and that's just going to be that channel gets blocked out and you use all the others. So it won't really be a major issue to you. So now that this database setup has been confirmed and set up, now we're going to start to see external antennas on 6 gig APs. Now, the next question then comes, when are we going to start seeing Wi-Fi 7 devices? Now, remember what I said earlier, it hasn't been fully adopted yet. Now, that doesn't stop the consumer brands from diving on it, because they're all about, I don't want to say a cash grab, but it's all about making money and profit and churn. And they know that the average consumer will replace their systems more frequently than a business will. The business grade systems, or your commercial grades, things like Cisco, Meraki, Aruba, Ruckus, the bigger names, they're not shipping their Wi-Fi 7 devices yet. Some of them do have some devices that are in trial mode, but they're not actually shipping actively. Some of these entry-level chipsets that came out in some of the consumer devices may also not have all the features of a true Wi-Fi 7 device. And so there's always that issue of waiting until it's been approved versus trying to jump the gun. Now, Aruba has announced as of April their tri-band devices. They said they'll be shipping sometime in late August. I have actually had a conversation recently online with a gentleman who did a major event using those devices, and they had a lot of great success. So it's encouraging to see what the Wi-Fi 7 products are bringing. Right now, the analysts are saying it's probably going to take 2 to 3 years, maybe a little bit more, for full adaptation of Wi-Fi 7. And then Wi-Fi 8 may not be until sometime around 2028, according to the currents. And the reality of it is, is it really going to benefit you? And these are the things you have to start looking at. You know, there are benefits to be had today that are more important than waiting 2 to 3 more years to get those benefits. So why do we care about Wi-Fi 7 today, even though it's not really there yet? You need to understand how it fits into your strategic plans. Also, a lot of what's available in Wi-Fi 7 is available with 6E devices, specifically the 6 gigahertz. So it's important to consider that and maybe make the jump to 6E today and plan 7 or 8 later down the road. If you're running an aging or failing system, can you wait 2 to 3 years? Chances are probably not. And then one big thing to keep in mind is that if you're going to make a move to 6 gigahertz, this is not going to be a one-to-one swap with existing 5 gig access points. The coverage area of 6 gigahertz is going to be diminished, just like the coverage area of 5 gig was diminished from 2.4. And so it's important to rethink the design, especially in some of these larger facilities that may have been designed 7, 8 years ago when 2.4 gig was considered, a primary use still. And so if your access points were set up for that level of coverage, or if it was strictly designed for coverage, not for capacity, not for density, then you're liable to find that you have a lot of gaps in your coverage when you move to a Wi-Fi 6, or I'm sorry, a 6E or 6 gig device. So what defines some of these challenging environments? So let's take a look at these. So the first thing we look at is size and layout. When we see large open spaces, tall ceilings, things like cubicle farms, retail stores, conversion properties like a store that's been converted to a church or a factory that's been converted to office space, arenas, church sanctuaries, auditoriums. These are all types of things that we think about. As you can see as an example here on the picture, we have a 4,000 seat sanctuary in a church with ceilings that run from 40 to 50 feet high. That's a challenging environment, especially if you think about the width of the environment and where do you put your access points? Do you put them on the wall? Do you put them on the ceiling? Do you do them like a stadium and put them under the seats potentially? So there's a lot of different options here that you have to consider. Taking a look at some other examples, and bear in mind, these are all places that we've done wireless designs or wireless work in, and some of the challenges that come in there. So for example, a cubicle farm. If you have a large open space, and in this particular one up here on the left, that was about a 550-foot long office area and about 200 foot or 300 foot wide. Nothing but cubicles. And the issue with this is, number one, you've got a lot of obstructions in the middle. So you have a couple of conference rooms in the middle. You have the posts that carry down all the electric. There's air vents and there's support columns. Not to mention then also the cubicles themselves. So the cubicle walls are made out of metal and a lot of reflective material. Plus this is in a downtown environment. Luckily for them, it was on the top floor, so they only had to deal with the floors below them. But there's a lot of noise in an area like this. And then also, the more APs you put up, the more chance you risk creating your own noise. Similar to that is the warehouse environment, where they have a tendency to mount the APs up on the ceiling because they want to get the coverage as widespread as possible. In this particular warehouse, this is about 40, I believe it was about 40 feet up to the rafters. The racks were stacked up pretty high, and you're looking at an area where all the APs will see each other, but they're not going to see the users down inside the racking areas and in the aisle space if it's not designed properly. Similar to that, industrial areas and other types of tall ceiling areas, such as an aircraft hangar or a factory. These are all places that have challenges. The aircraft hangar is an example of a variable load where the planes move every day. And so you don't know where you're going to be placing your coverage. Other types of things we might look at, the construction. So when you get into some of these challenging environments, you have unique construction issues. heavy timber, concrete, brick, stone, stucco, thick, heavy walls, metal sheeting, decorative features. A great example in this one, it was in a school, it was a ship bridge simulator. And so all of those screens wrapped around that area created a very difficult area to get RF through. And so you have to address certain types of things with these types of features. Storm-proof construction, especially down in Florida, for example, can create a lot of challenges with the heavy concrete. Old schools or old churches, old historical homes. And again, back to the conversion properties again. So some examples that you might see in your own environments, things like taking an industrial site and turning it into a brew pub with all that metal and all the lights hanging down and all the plumbing, or a high-rise office that's built into an old warehousing facility in New York City. There's plenty of these in the Baltimore metro area as well that have been converted to offices. Again, cubicle farms with high open ceilings create challenges of mounting, or in this case, a classroom with a lot of metal piping that was for the utility or for gas utility training room. Other types, and this is a great example of modern construction mixed with old construction. So this particular resort burned to the ground sometime in the early 1900s, I'm sorry, mid 1900s, was completely rebuilt with modern construction, but yet maintained the old look and feel. And so a lot of the old structure was put back on, or the old molding was put back on. So there's a lot of heavy timber in this construction, a lot of teak. That's actually a room in this hotel up in the upper right-hand corner. It was made to kind of feel like you were on an old sailing ship. So there was a lot of teak and bunk beds, and it was a real interesting mix. But these are the types of things you run into in old estates or old school buildings and other types of places that use heavy timber construction. The other type of area is the urban or metro area. So this is the metro office space. Also areas that have heavy foliage involved. And so as an example, to place this particular office, as you can see, you've got some construction challenge with a heavy glass office wall. Glass is actually one of the worst offenders to RF, considering that a lot of it has ultraviolet protections in it. This glass was no different. The interior glass was UV rated to avoid too much sun coming from the exterior windows on through, because the older exterior windows were not coated. To kind of position this, outside this window is about the spot where Captain Sully managed to put a 737 into the Hudson River. So that kind of gives you an idea. It's downtown New York City, and very difficult area to work in as far as for RF. So no different than Baltimore, Washington area for some of your high-rise areas. Another one that we're going to use as a case study is this office overlooking St. Patrick's Cathedral. Another one positioning it, in a very dense area of New York City. That's the view out of their conference room. And so right from that area, there were about 400 or 500 competing wireless networks. Another one, office parks, a lot of them are starting to get fancy with some of the interior design work. In this particular case, again, the interior windows were UV rated. We had foliage in the lobby, but then there was more foliage in the offices that was creating challenges of trying to get the signal through the various different areas. Outlet malls, I think there were something about 400 or 500 APs, or I'm sorry, competing networks found in this particular outlet mall. And so if you're even, let's say you're an office near that outlet mall, you're going to have challenges as well. And then we also look at things like the population or the use case as being a difficult environment. Some things such as the number of devices per person. And so, for example, in a senior living facility, years ago, and I'm talking about 5-10 years ago, we thought about each room having one device. So the typical resident had a phone or a laptop, and that was it. How many electronic devices does the typical resident have today? if they're in their, say, 60s or 70s, it's not uncommon for them to have 3 or 4 devices per person. So we're talking, a watch, a phone, a laptop. Add to that all of the other types of devices that they may use in their house: sensors, monitoring devices, security cameras, all of those types of things start to increase the number of user devices present, and then potentially increase the risk of devices that are also broadcasting SSIDs and competing against the network you're building. We look at the density of users and what types of use cases are driving the capacity needs here. Is it a lot of streaming? Is it a lot of video calling, or just even Wi-Fi calling? So when we see these types of environments, we're thinking schools, hotels, apartments, hospitals, event venues. A lot of wineries and vineyards are doing outdoor events. This is a vineyard that was doing a concert series, bringing in some pretty good big name events, about 5,000 attendees, 35 vendors, trying to get wireless out there into the field so that they could run credit cards and provide access for the artists and others. Large private schools. This school was actually an old hospital that had been converted, and it was built during World War II, so it was built to withstand potential bombing. And therefore, all the walls were double concrete walls, very difficult to penetrate. Hospitals and all the challenges that they bring about. An operating room has a tremendous amount of metal in it that creates a shielding issue quite often. Or in the case of the one at the bottom, an engineering college, large classrooms, labs with a lot of things like fume hoods. And so that can create a very challenging RF environment to work in. And then the rest of the fun places that we like to throw out there, we think about any place with a large crowd, dynamic load, high RF interference, and potentially things like liquid storage. So these are your event venues, like this wedding event venue that could go from 20 people to 200 or 300 people at a moment's notice. Other areas like a brewery with all of the liquid that's stored in all the containers and such. Or in the case of this one on the right, upper right, it was an industrial facility converted into a shared workspace. And so there was a lot of metal, a lot of tight spaces, a lot of wood, again, a lot of UV rated glass inside as well. And then others are things like your high ceiling and dynamic loads in a warehouse, or in the case of the one in the lower right, these vaults, these wooden boxes, you don't know what's in them. It could be furniture, it could be artwork, it could be appliances. It's a varying load in a storage facility. So what are the issues? What are the things that you may be experiencing in your large environment? And honestly, this applies to any wireless environment, but these are things that are more specific to the larger environment. So some of the symptoms you may be experiencing: slow loading of your web pages or network applications. Users will say, things are just running slow. Garbled VoIP or Wi-Fi calls, lost wireless connections, delays trying to connect, not being able to connect at all, or worse, and this is the hardest one to troubleshoot, as you probably well know, the problem moves. So today it's in this corner, tomorrow it's over here, the next day it's down the hallway. So if any of these are applying, or you're seeing some of these, what could be causing it? And so we'll start with the wireless causes. One of the big ones we find, obviously, not enough access points. Sometimes it's too many access points. It can also be the wrong access point, which we'll talk about more. We run into channel reuse or overlap with bonded wide channels. So without getting too deep into the weeds on how the spectrum works, if you're going to go for the highest possible throughput, you typically go to 40 or 80 meg wide channels. That causes there to be less unique channels available. And when you have more APs, it becomes more difficult to avoid reuse at that point. And so there are ways to handle that, and we'll talk about that in a bit. One of the other areas we see oftentimes is the power is running too high. So the coverage cells tend to overlap too much at that point. Sometimes you'll hear the problem referred to as a sticky client, and it's a client hanging on to an AP further away than one that's closer. And the challenge there is clients make the decisions of when to roam, not the access points. And the client devices all do it differently, and they're very lazy about it. So they're not going to have a tendency to change unless they've hit a threshold that requires them to do so. Other issues that we might run into with wireless include poor placement of the access points or obstructions such as HVAC systems, machinery, walls, and such. And another big one that we see is that it was designed for coverage, not capacity or density. And so the focus when it was designed was on signal strength everywhere, and that's how they test it. They run around with a phone or a laptop and they go, well, I got neg 70 here, I got neg 68 here, and that's all they're looking at. If all you're looking at is signal strength, you're missing the big picture, because signal strength is just one small piece of all of this. There are other elements that combine to give you a good wireless or a bad wireless experience, which we'll get into. Some other wireless causes: interference from your hotspots from phones and printers or AV systems. So a common one we run into in churches and schools, they'll have an AV system for the auditoriums or for the speakers, and they're based on 5 gigahertz oftentimes today, and they're competing for the same frequency space. Hotspots from the phones. So when everybody shows up in the auditorium and they all have a hotspot turned on their phone, that can add to the misery that you're having in that particular area. Too many users per access point, so you don't have a good balance, or you don't have access points that are capable of handling the user counts that you're looking at. A single poor client connection can draw down the experience for everybody on that AP as well. So if you have one client hanging on to it and struggling to stay connected, it's going to drag down the experience because it's going to take up more airtime. Some other wireless issues that we run into: the wrong AP, which we kind of talked about, the antennas misaligned, very common in a warehouse with external antennas. If they're not placed up out of the way, sometimes they get bumped and thus pointing in the wrong direction. We also deal with distance, so too far from the AP itself. And then there's also other causes not related to wireless that can affect these environments. So for example, your network issues, such as your DHCP pool being empty, or running into STP issues on switches, congestion due to a daisy-chained switch situation, upstream issues with your ISP, overloading your internet upload, or just flat-out wiring issues of various types. So how do we work with these challenges? What do we do to get around them? So one of the first things you want to do is you want to pick an enterprise solution to work with. This is a vendor that has a variety of device types to meet your various needs. They're not just a one-trick pony with one access point. They have low-end models, mid-level models, for small conference rooms. They have high-density units for areas of large concentration. They have outdoor units. Maybe they have intrinsically safe units for areas that require electronics protection so that you don't start a fire. And then there's other types of APs: directional versus omni, large crowd versus smaller crowds and such. You want reliable firmware releases, so you want a history of reliability with this company. You want well-documented products that support the current technologies. Stock is available through distributors or direct. They have a stable history of development, and solid support is a very important part. That's not just support from the vendor, but also support from consultants and engineers that you can engage, as well as a strong online community for those types of things that you can just reach out for a quick answer. You also want to conduct a professional design. This is something done by a trained professional with extensive wireless experience. They use professional grade tools like Ekahau, Hamina, IB-Wave. These are products that typically run in excess of somewhere between $5,000 and $10,000 each. IB-Wave's probably like the gold standard for stadium builds, runs about 20,000, well, somewhere between 15 and 20, depending on the licensing. So these tend to get very expensive, a lot of learning involved in them, so a very high learning curve, plus licensing and keeping them up current. But a good developer, a good designer will also factor in your use cases, the environment, your future needs. They're going to design for the density and the capacity, not just getting coverage. It's not about checking off the boxes and seeing a nice, pretty green heat map at the end of the exercise. I want to see heat maps for other things such as signal to noise ratio, channel interference, channel overlap, and things like that that we need to design for and take into consideration. A good designer will also test the construction materials using industry-proven methods to try to figure out what does that wall do to the signal? What does that window do? What is that floor or ceiling doing to it? What about the machinery and the file cabinets and all the other things that are involved in your environment? So some of the benefits of having a professional design done, one of the things is that you can get a realistic budget so that you know what you need and when you're going to need it. You can also, by doing a professional design, you can avoid scope creep because you have a document that states, this is what we're building. And so you have something to match that against to what's actually coming out in the end. It helps you avoid costly placement errors and rewiring. Yeah, if you have hard ceilings, for example, and you've got to fish wires through the ceiling, you do not want to have to move APs when you're done. If it's all drop ceiling or open ceiling space, it may not be as big of an issue, but you still have to factor in the time that it takes to go up, move an AP, possibly run a new wire to extend it, the downtime, the aggravation. And that's kind of where this next one comes in. You avoid annoying users due to a lengthy trial and error tuning exercise. So this allows you to basically go live day one with a functional network that just needs a little bit of tweaking versus potentially a lot of tweaking. It also lets you select the right access points and antennas and not waste a lot of money on having too many, not enough, or getting the wrong devices altogether. So with professional tuning, this is something else you can do. This is kind of like a new design, but it's more focused on fixing the current issues. It focuses on things like channel selection and width, power issues, other features of the controller, maybe a network review to look for any issues there, like the DHCP or DNS challenges. Find the sources of interference, find where your coverage issues are. Take a look at the whole entire environment from the top down and figure out what you can do to get by until you can do something better. Professional tuning is, it's very important. There are some things you can do by, checking the coverage, checking the DNS issues, your DHCP issues, making sure your STP settings are correct on your switches. But then, getting into the spectrum analysis and trying to figure out the signal strength issues and such, you might need to bring in a professional with that type of gear to do that type of testing. The other thing is when you're designing, we want to design now for density or capacity, not just coverage. Coverage is all about signal strength. And so it's very easy to have good coverage, but then have interference that's causing the coverage to not work as well. And so when you're testing with a phone or even a laptop, just walking around using a basic thing like Wi-Fi Explorer or any of the other myriad of applications out there that do this, all you're seeing is signal strength. You're not seeing the SNR, the signal to noise ratio. You're not seeing channel interference. You can figure it out if you read it long enough, but it takes a lot of time to analyze that data. We look at, when you're designing for density or capacity, we're looking at the user counts, the use cases, And we're always designing for the weakest link, which is the client device. So we're always looking at the client devices and figuring out which one is the worst one in our environment. Now, in a case of an office and a warehouse combined, the weakest link may be the hand scanner, and that really only applies to the warehouse. In the office area, the weakest link may be our cell phones. And so we can split the area and design differently for each area, not just a blanket, one size doesn't really fit all type of design. We can get very specific about that and make each area work best for what is done in that particular area. And trust me, if you're designing for a hand scanner in a warehouse and you walk out there with the cell phone will work fine if the scanners are working. If you design for a cell phone in the warehouse, the hand scanners may not work. So again, you got to pick the right area, the right device. Some other things to look at: investing in your infrastructure. Moving to Wi-Fi 6 or Wi-Fi 7, you're going to have to consider potential upgrades to your infrastructure. For example, many of these newer APs have 2.5, 5, or 10 gig NIC cards in them. And so if you want to take full advantage of the capabilities of that access point, you need to support at least 2.5, if not 5 gig Ethernet connections to the access point. So that may require rewiring, it may require new switches. The PoE needs go up considerably. So many of these access points now require 802.3 AT or even BT for power. And so the simple switch that you might have today may only support 802.3 AF. And so you may have to look at upgrading those. Along with that, you may have to upgrade your UPSs as well as your HVAC in the closets, because when you add more switches or higher end switches, you're adding more heat in that closet. Also, when you're looking at the PoE, you need to look at the max draw for that AP, not what the current actual use is, because actual use might be very low compared to what happens during an upgrade or what could happen with a future firmware update. And we've seen that with other, with many different brands. Today, it may only use 6 watts. We issue a firmware update, it spikes it up to say 10 watts, and then it holds there and stays at say 10 watts, or maybe it backs down a bit, but now it's 9 watts all the time. And so that's important to keep in mind. Whatever it's rated for is what you want to design for so that you don't get caught short. Again, you may need to upgrade your wiring. Also look at fiber between closets if you haven't done so already. You want to probably get somebody qualified to do network engineering and cabling to take a look at the whole entire structure. Get a cabling consultant in there to look at your wiring. Make sure that you don't have any hidden surprises. If you're in an older structure or something that was wired before you took occupancy and you're not familiar with what they put in there, check the wiring. Oftentimes, low-cost wiring contractors will use something called CCA, which is copper-clad aluminum. Copper-clad aluminum works great over short distance. However, it doesn't carry power very well. And so over long distance, it overheats and the power goes down. So you get too much voltage drop and you won't get the PoE that you need to the distant APs. In addition to the fact that it does overheat, which is a problem, it's not really considered a safe wiring and it's not recommended anywhere. It should always be solid core copper. So what can you do to get by for a bit? Considering that maybe you're going to be in a 1 to 2 year cycle before you do your upgrade, what are some things you could do? So by doing a design today, you can use it to budget the project correctly. I want to give a really good case in point. It was involved with 2 very large global firms. Both of their CIO departments or their IT departments, the head of them, went to their board of directors this a couple of years ago and estimated a 50 to 75% increase in the number of APs. Now, this was not going to a 6 gig solution. This was going from predominantly 2.4 to a all 5 gig design with the future, to take advantage of all the other things down the road. So they looked at what they had today, and if they had 100 APs, they figured they would need about 150 to 175 when it was done. And so they went to budget with that number in mind. Now, each of these had over 500 locations worldwide. When the designs started rolling in, and these were done by professional third-party designers, they were finding that they were actually needing more like 300 to 400% increase in AP counts. So instead of 150, it was more like 300 to 400. That's a major difference in budget. And so they had to really step back and rethink it. What it boiled down to was that change from a 2.4 design to a 5 gig design was so dramatic that it really threw their budgets off, and they didn't realize how dramatic it would be. It wasn't an intentional mistake or oversight, it just was a lack of understanding of the technology and how well it actually worked or didn't work. So by doing this now, it gives you the time to start thinking about what it's going to take to get there. You can start lining up your contractors, you can start dealing with supply chain or labor issues that come up. It gives you a little bit of a buffer. And then you can stage your upgrades based on the availability of the parts or contractors. So for example, you could address your HVAC issues today, or you could address your wiring issues while you have a chance and minimize your impact later on from a number of different factors. So you can also do a performance tuning study on the existing network. So let's try to make the existing work as best we can for the year or so that it might take you to get to the next level. You can look for simple things such as channel and power management, fix any routing issues, improve your firewall, maybe add just a couple of APs here and there, not a major upgrade, but just a couple here and there that would help solve some problems and gaps in coverage, or maybe move an AP a little bit to cover an area a little bit differently. It's a good time now to tighten up security, change your passwords, look at different ways of doing authentication. Basically, you're trying to make things tolerable until you can do an upgrade. Look for your DHCP, DNS issues, review everything else, your cabling, HVAC, power backup, physical security. Here are some examples that we just ran into recently. Working in a cubicle farm, they had wireless performance issues. They were losing calls, poor coverage in a warehouse that was attached to the building. The performance tuning survey uncovered bad channel management and power settings. Turned out the auto tuning wasn't working very well. And this is oftentimes a problem, even with your big names like Cisco, Meraki, Aruba. They love to tout how great their controllers are, but there's times in certain environments where their controller just cannot keep up with all of the different issues going on. Moved a couple of APs in the warehouse, added one, moved to Wi-Fi 7 when it's available. That's their plan. And now they have a wiring upgrade plan in place as soon as they can get a contractor to get going. Similar issue, schools over the last, they're planning on moving to Wi-Fi 7 in 2 years. They had various issues, channel and power management, and they needed to build a budget and start getting their plans in place. So good ways to actually try to make use of the time. And so let's take a look at some actual case studies and how these problems were solved. So going back to the church from the beginning, Sanctuary seated 4,000, needed access to stream out live feeds by every single person in there. Never in my life would I have imagined 4,000 people needing access in a church, but that's what they wanted. The current solution was Zyxel. They were mounted wrong. They were never really working. These are fantastic APs in and of themselves and should have been able to handle 4,000 users no problem. Unfortunately, when they're mounted upside down and too low to the floor, it's not going to work. The other issue is that things had to blend in. We're dealing with tall ceilings, wall mounts were out because they didn't want to see them on the side. In this case, the solution was a Meraki base, 8 MR86s in the ceiling, some number of high capacity units outside in the hallways, and then a couple in the sanctuary up underneath some areas to add some coverage. So the results were that we got a predictive coverage match that matched actual coverage, which is the ultimate goal. And so the idea here was these are indoor units with external antennas. You can see they were mounted up in the rafters with antennas pointed out over the audience, so that these created very narrow focused coverage cells. And so we had a total of 8 coverage cells on the main floor to cover all the main seating sections. So in some cases, actually in the one in the lower right, it was actually over top of a piece of fabric pointing down at the back. So you didn't even see that AP at all. And here circled in red is an example of one of these antennas. You can barely even tell that it's there, as opposed to the old Zyzels, which are circled in blue down low and pointed upward at the ceiling. By the way, they actually worked great for the folks in the upper balcony seats, but everybody seated below got absolutely nothing from them because these were truly designed to be up above. Another example, and this might apply to many of you in the Baltimore metro area or down in the DC metro area. This was a Midtown Manhattan office. They were experiencing garbled calls, slow web page loads, over 500 SSIDs being broadcast. The end result solution was kind of unique. They only had 4 access points. We ended up putting them all on channel 165, which is in violation of good design, but because nobody was using that channel anywhere to be found, it actually worked out better to suffer their own interference rather than suffer at the hands of everybody else. With this particular office, we did a Wi-Fi spectrum analysis. We discussed the situation with the users. We found all their APs because they were all hidden. Went through the analysis, made the changes, tested it while we were there, and the end result was everything worked again. One of the big culprits we found in this facility was this little thing in my hand in the middle, which is a click share device, and it was a screen sharing device that was broadcasting on a wide channel and creating interference. Additionally, you can see where their APs are. They're up above the ceiling or up above structural elements that had a lot of metal in them. And so it weakened the signal strength in those areas. Another one in Metro New York City, a lot of unique items. This is an office that you saw earlier that I'll talk about. There were columns, as you can see in the pictures coming up, that were broadcasting, well, they were showing interference when we got close to the columns, and yet there's nothing physically there. This interference was coming from 11 floors below and was transmitting up through the columns through the metal in them. And so they were acting as antennas. This is not uncommon in a high-rise environment. You can see these columns in the middle of the floor. Basically, we could not put an AP within 10 feet of these things, or it would start to have issues with everybody else's stuff down below. Again, there's the office, with the heavy glass that we had to deal with. That's all UV rated, so signals wouldn't go through it very well. They also had a lot of stainless steel kitchens that were used for filming, or model kitchens that you can see here. So you had a lot of theater lighting up above that was in the way of the devices, and things moved constantly. This kitchen's been remodeled 3 or 4 times since this design was done. So they keep changing the cabinetry, the layout, the lighting, and so your design has to be flexible for that. Taking a look at a .com retailer's warehouse. This is an older system that was failing. We were not able to visit the site due to the urgency. Basically, we had 2 weeks from start to finish, or about 3 weeks actually. So we did a predictive design using good floor plans. They did a video walkthrough for us, so they were able to send us video footage of what the warehouse looked like. High ceilings, 40 feet up, racking. This is a gift basket retailer, so the contents varied It could be a bag of potato chips in aluminum foil. It could be fresh fruit. It could be some gift item like a stuffed teddy bear or something like that. So it created a lot of different challenges because you never knew what was in one rack to the next. Very long, narrow aisles. So this is the view from about 40 feet up. And then 1 minute they're full, and the next minute they're completely empty as product moves from one area to the next. And so the design has to be able to just deal with those types of challenges. You're also dealing with very high ceilings, as can be depicted here. I'm all about safety, so that is actually, me being very safe there. I sent somebody else up to do that. That somebody else happened to be my best partner and wife, but she's up there hanging APs at 40 feet up to cover the production area because there's nowhere down below to put them that they aren't going to get whacked by a forklift or a piece of equipment. Another room that was very evil, the popcorn room. I got to say, every time I walked in there, I walked out of there wanting to eat the entire place out because the popcorn smelled pretty good. But that's a challenging room. It's a tall ceiling, the load changes, things move around. To give an example of what it looks like, the drawing on the left was how we predicted the coverage in the warehouse. Green is good, gray is not so good. The areas that you see in gray are inside the racks mostly or inside the cooler. That was acceptable to them. The image on the right shows the final design. So the final and the predictive are fairly close, which, we'll take this as a win. And that's what we aim to do with these types of designs. So to kind of bring it to a close, keep in mind Wi-Fi 7 is coming. It's about a year out, give or take. We're going to start seeing devices showing up over the next couple of months. If you're urgent to move today, consider Wi-Fi 6E devices, since they have basically all the features that Wi-Fi 7 will have, specifically for the support for 6 gigahertz. If you have a large enterprise or challenging environment, remember it requires extra attention, a different experience level to handle the wireless issues. It's not as simple as just throw up a couple of APs and hope it works. The issues are the same as a smaller environment, but they're just more amplified. A gap in coverage could become more critical than a gap in an office area. For example, if there's a gap at the corner where the cubicles meet, it may not be an issue. But if it's a gap at the corner of where 2 racks meet and a forklift drives around the corner and loses connection, that may require that forklift operator to stop and re-log in, which could be problematic for production. Make sure you're using enterprise solutions to solve enterprise challenges. Select your design and your consulting partner with the right level of experience. Make sure they know what to do with these large environments, and be comprehensive with your assessment. And with that, Chris, I'm going to turn it back over to you.
Thank you very much, Alex, for the rich amount of information there. So I don't have any questions at this point. So I will just point that in the evaluation that you'll receive this afternoon, if you wanted more information about a planning workshop to kind of talk through some of these issues for your environment, we can certainly offer that. There's no charge for that, because that may include either various kinds of solutions depending on what kind of challenge or what kind of installation that you're looking at, whether that's a design or survey or troubleshooting, those types of things. But all those options are right there on the survey, and hopefully we'll also go ahead and pull some of those completed surveys for either the Amazon gift card or the favorite restaurant to hopefully make it even more fun for you. So thank you very much to each of you today. We'll give back the remainder of your day, and thanks again to Alex for the great information. Have a great day, everyone. Thank you so much.